Now look at the nullclines defined by this two-species competition model. I'm just copying from the last slide, and let's now plot the nullclines in the state space defined by the densities A and B. First, let's look at the special case, or the extreme case, epsilon is less than minus 1. So we have fixed points at A equals 1, B equals 0, and another fixed point, obvious fixed points at B equals 0, B equals 1, A equals 0. But let's look at the nullcline. So for the B dot equals 0 nullcline, it's a line B is equal to 1 plus epsilon A. When epsilon is less than minus 1, this is a line of slope less than minus 1. And so the nullcline looks something like this. It starts at, when A equals 0, it's at B equals 1, and it has a slope larger than minus 1. So this is the nullcline B dot equals 0. And then on either side of the nullcline, it's easy to verify that the flow looks like this. Similarly, the nullcline A dot equals 0 starts at A equals 1, B equals 0, and it looks symmetrical, and so it does something like that. So this is the nullcline A dot equals 0. And again, the flow on either side of these nullclines looks as so. So we have where the nullclines intersect, there is a fixed point. And then there were fixed points here where we have just single species evolution. Let's now look at the flow in each of the four quadrants defined by the intersection of these nullclines to figure out what the global flow looks like. Below both nullclines, the flow is up and to the right. To the upper right here, the flow is down and to the left. In this little wedge, the flow is down and to the right. And in this little wedge, the flow is left and upward. So now we can infer what the global flow looks like. It turns out that the symmetrical fixed point where there's coexistence of the two species is actually a saddle point, whereas these are stable fixed points. So in this case, when epsilon is less than minus 1, the competition is so strong that the system would prefer to have one species die off and you just have single species population in a steady state.